Welcome to Note 6.1. Today we're going to talk about the Cartesian coordinate system and introduction to slope. Both of these are huge concepts for this unit, so really make sure you're grasping what the Cartesian coordinate system is and what the slope represents. So, what is a Cartesian coordinate system? It's formed by the intersection of two lines, which we call the horizontal axis and the vertical axis. And we have them intersect to create these four different quadrants in the same plane, and that creates our coordinate system. This coordinate system is named after the French mathematician René Descartes, who formalized its use in mathematics. This Cartesian plane and its invention changed mathematics forever. In analytic geometry, we can represent points, lines, circles, and other curves using Descartes' system. In fact, if you've used Battleship, you probably are fairly familiar with what a coordinate system is. So, a couple facts here. There are two axes. The horizontal axis, which we sometimes refer to as the x-axis. So let's fill that piece in. So our x-axis is this horizontal one right here, which we'll label with the x-axis. We also have the vertical axis, which is our up and down one, which we call the y-axis. Unless a scale is given, we always assume that one tick mark represents one unit. So in other words, what that's saying is if this is 0, this line here is 1, followed by 2, 3, 4, 5, and the same is true for the y-axis. The plane is divided into four regions, which we call quadrants. We number them in a counterclockwise direction, starting at the top right with Q1, and then we're going to go counterclockwise and label. So what that means is that Q1 is this first box up here, Q2 is the next box, then Q3 traveling around in a counterclockwise direction, and lastly we have Q4 in the bottom right corner. The origin is the point where the axes intersect. So our origin is this middle dot right here, and it's labeled by the coordinate point 0, 0. So here we can fill in that the coordinates of the origin are 0, 0. And that's because I'm sitting right at this middle point. I haven't traveled to the right or the left at all. And I also haven't traveled up or down. So both my x values and my y values are both 0. When we give coordinates, we give them as an ordered pair where the first coordinate is the position with respect to the horizontal number line, which we often call the x coordinate. And the second coordinate that we indicate, being the positive with respect to the vertical number line, is often called the y coordinate. So in other words, if I write a coordinate point, which is represented by brackets with a comma in between, we'll always have our x coordinate go first, followed by our y coordinate, and you can remember that order by remembering that it goes x then y in alphabetical order from left to right. So one thing we might notice when looking at our quadrants is that we're going to have a pattern between positives and negatives. So for example, in Q1, because I'm traveling with respect to the origin into the positives on the x-axis, we're going to have a positive value for our first number. And then because our second number is also going up, no matter where I am in this coordinate, then that means my y value is also going to be positive. So in Q1, both our x and our y coordinate are both positive. This changes a little bit in Q2 in that now, relative to the origin, I've traveled to the left, or in other words, into the negatives on the x-axis, in order for me to be lying somewhere in Q2. So that means that our x-coordinate is going to be negative, but because we're traveling up to get into Q2, we're still positive on the y-axis, so our y-coordinate is going to be positive. Rotating around to Q3, we want to see what is our x-coordinate doing, what is our y-coordinate doing. In this case, we're traveling into the negatives on the x-axis, and we're also traveling into the negatives on the y-axis. So in this case, we're going to have negative x values and negative y values. And we'll put this into an actual number example in example 1 below, just kind of going over a general pattern that we should see and that we can check against our answers. In Q4, we're traveling into the positives on the x-axis, so our x-coordinate will be positive. However, we're traveling into the negatives on the y-axis, so our y-coordinate is going to be negative. So you can see that each quadrant has its own distinct coordinate pairs, and the coordinate pair positive and negative in the x and y positions should give us a good indication as to what coordinate we are in. So let's put this into an example. For this example, we're going to write the coordinates of the points plotted on the following grid. So starting with A, we have a point right here, and we're trying to see what are the x and y coordinate values for that point. In other words, if we were playing something like Battleship, how could I describe A's position within my Cartesian coordinate plane so that I can describe where that point is? First, we want to look at where this A value is on the x-axis. Because I'm lined up with -5 on the x-axis, remember this is the x-axis, so where am I lined up with? Then we're going to have -5 in the position for our x-coordinate. For our y-coordinate, we're looking at where this lines up on the y-axis. In this case, we're lined up with +4 on the y-axis, so our y value is going to be +4. Okay, now let's do it for B. So same thing, we're finding what's the x-coordinate, what's the y-coordinate. We're looking at the point right here, which means in this case, we haven't actually traveled to the right or the left at all. So because we're sitting right on the y-axis, our x value is actually 0. Because we're at +1 and -1 on either side, this origin point here is 0, meaning that our x value is 0. We have moved up 1 square on the y-axis. So for our y coordinate value, we are at +1. Okay, for C. And if you're feeling okay with this so far, see if you can maybe pause the video and give these a try and then check your answers. For C, we're lined up with +1 and +3, meaning our values are going to be 1 for the x-coordinate and 3 for the y-coordinate. Okay, now for D, we are at 5 for the x-coordinate and +1 for the y-coordinate. For E, we start to travel into the negative, so we are at -2 on that x-axis, and we are at -4 on our y-axis. So we're filling in -2, -4. And for F, we're sitting 4 spots to the left of the origin, so at -4 for our x-coordinate. And for our y-coordinate, we haven't moved up at all, we haven't moved down at all, which means we're sitting at 0 on the y-axis. In other words, we have no height to that F point. We're now going to add a few points to our graph. So we're going to plot G at 4, -3, remembering that our coordinate points are x, then y. That means I'm going to count over 4 spots to the right of the origin. So 1, 2, 3, 4. So where x is equal to 4. And from there, we're going down 3. So I go over 1, 2, 3, 4, down 1, 2, 3 to -3. And that's where we're going to plot our point at 4, -3. We want to make sure we label it with the appropriate letter so that we're indicating where that point is. For h, this time we're traveling to the left of the origin to -2 on the x-axis, and then we're not going up or down any since our y value is 0. So that means our point h will be sitting right on the x-axis at a value of -2. I is right at the origin, meaning if we're at 0, 0, then we're in the dead center of the graph, and we label that with its letter I. Okay, let's do an introduction to slope. This is a very, 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 very big concept in the grade 9 course. So just make sure that you have this concept down as we'll build on it throughout the video. So make sure that you're asking good questions and any questions that you might have if you find that there's something you don't quite fully understand about this topic. So in mathematics, the slope, or in other words, the gradient or steepness of a line, is a number that describes both the direction and the steepness of the line. Slope is often denoted by the letter m. So in other words, slope is equal to m, and we'll often see the slope being represented by the letter m throughout this unit. Slope is calculated by finding the ratio of the vertical change, which we refer to fondly as the rise, to the horizontal change, which we refer to as the run, between any 2 distinct points on a line. So our slope is equal to m is equal to our rise over our run. So these are kind of the ways we like to talk about slope, and we will interchange throughout. So just know that all of those are equal. So what are we talking about when we're talking about the vertical change, or in other words, the rise? So when we talk about the rise, we're talking about the vertical distance or difference between the 2 y coordinates. So suppose I told you that there were these 2 nice points on this blue line where we've identified whole number coordinates of -3, -2, and 4, 3. Essentially, we've picked 2 points where our blue line nicely crosses through exact grid lines so that we can read off whole numbers. If I were to choose this point right here, for example, I'm kind of halfway between 1 and 2, but it looks like it's maybe a little more than half, and we don't really want to be guessing when we're trying to find a super accurate slope. So when I talk about the rise of a graph, I'm talking about this distance right here. So from this first point, as I travel up to this point, kind of ignoring that diagonal, how much have I actually gone up by? And there's kind of 2 ways I can look at it. I can look at if I were to draw a dashed line from the 2 heights, how much have I gone up by here? And this would be 5 squares. Or how much have I gone up by here? Also 5 squares. So you're looking at the rise, or in other words, the change in the vertical height between our first point to our second point. Ignoring the horizontal travel, just how much have I rised by from the y coordinate? So in this case, because I've gone up by 1, 2, 3, 4, 5 squares, we would say that our rise is equal to 5. That's the vertical change. For this same graph, so we have points at -3, -2, and 4, 3. We want to look at the horizontal change, or in other words, what we call the run. Okay, so our rise is our change in our vertical, but our run is the horizontal distance or difference between the 2 x coordinates. Okay, so the fact that this is between x and the vertical is between y is going to be an important concept. So in this case, when we're looking at our run, we're looking at between these 2 points, how much distance have I changed horizontally? And in this case, our run is equal to 7, because if I were to draw and look at just the horizontal distance between these 2 points, I've traveled over to the right by 1, 2, 3, 4, 5, 6, 7 squares. So to get from this x value to this x value, I had to go to the right by 7. So if we were to kind of look at our fancy little formula summary, we have that the slope is equal to the letter m, which we simply just use to represent slope, which is equal to the vertical change over the horizontal change, which we fondly refer to as the rise over the run, really because it has a nice ring to it and it's easy to remember. So if we were talking about the rise over the run for the question above, what we would do is we would write this as a rise of +5 over a run of +7. So our slope in this case would be m equals 5 over 7, because that's our rise over our run. So finding the slope of line segments. I'm going to read through these instructions quickly, and then we'll just do an example, because an example is going to be the easiest way to see this. So finding the slope of line segments. Number 1, we're going to find at least 2 distinct points to use. And as mentioned before, we want points that are easy to read on a grid. That means I'm choosing points that hit at exact coordinate points where I have these grid lines and the point that we've chosen is exactly in the middle of them. I don't want to choose a point like this where it's tough to guess. Am I at -0.6? Am I at -0.72? I don't know. Same with this. It's close to this value of 1, but it's not quite there, and so on and so forth. So make sure that we're choosing nice points where that line evenly crosses grid points and I can pull off whole numbers. Next, we calculate the rise, or in other words, the vertical change, just like we did here. We counted our squares. And then we counted our run. We counted how many squares to the right did we travel to get to the next point. And for our run, it's important that we always are counting from the left point to the right point. Okay, so let's keep in mind that when we calculate our run, we're always working from left to right. Okay, we use a positive number because we're going left to right, like we're reading a book. It's how many squares have I gained to the right. Okay, for this, we can only count straight up and down and straight left and right. So we're never counting on a diagonal of how I might go up here and then come back here, or go from here up to here. We're always simply counting in terms of our horizontal distance, and it's exactly on the horizontal, or our vertical change exactly on the vertical. Okay, so when we count our rise and our run, just make sure we're going on the exact horizontal versus the exact vertical. If we count up, then we say that the rise is positive. So in this previous example, we counted from this point to this point that we had gone up in terms of our vertical value. So this was a +5 over 7 slope where we were traveling up to the right, we were increasing, and we were getting positive values. In contrast, if we had a line that was the opposite way, down like this, then I would count how much distance I had decreased, and it would be referred to as a negative slope. We'll see this in a later example, so don't worry too much about that for right now. When we're talking about our run, we always run to the right. So like a book, we always run from left to right. So our run will never actually be negative because we're always increasing from a lower x value up to a higher x value. Then we are always referring to our run as being positive. When we're writing our slope, we want to make sure that we're writing it as an improper or proper fraction in lowest terms. So what that means, don't want to see any mixed fractions, don't want to see any decimals, and I want to make sure that those fractions are in lowest terms. Okay. Whole numbers are okay, but we should always be thinking of our slope as fractions. So what does that mean? If I got a value that was, for example, +5, a slope of +5 makes sense, but it's difficult to see the run. So when we get a whole number, we want to remember that every whole number is really over 1. So I have 5 wholes if 5 is my number, and it's 5 over 1, and we want to write it this way so that we can see the rise and we can see the run. If I don't write this 1 in the denominator, I can only see this rise, and that's not the most helpful when I go to graph it when I need to know what the run is. If the slope is negative, then it's best to include the negative sign with the numerator. So all that means is if I got a slope of -4 over 3, I want that negative up in the numerator. So in other words, I don't want a -4, oh, that's not drawn the best. I don't want a -4 with the negative sign in line with the fraction line. And even worse, I don't want 4 over -3. Although technically all these fractions are even, 4 over -3 is misleading in that I would have my run being negative. We discussed how we always want our up and down to be the piece that's positive or negative, and we always want our run to be positive. So if we have a negative, avoid including it in the denominator or out front. Although technically all these 3 are equal, this is the easiest thing to see that I would be going down 4 and right 3 in terms of my rise and run. Okay, let's practice determining the slope of each line on the following grid, remembering that our slope is rise over run. So for line 1, step 1 is to pick 2 nice points on our line. So I'm going to start with this one on the far left because it seems to hit at a nice grid point line right there. And then what I like to do is run my finger or pencil along the line and see where's the next nice point. And I can see there's actually one nice and nearby right at this next value 2 squares over. And I can plot a point there. Had I chosen this point or this point, it would be totally fine, and I'll show you why in a second. But I tend to find it's easiest to start at the furthest left and run my pencil along to find the next nearest nice point. For this, we want to remember that our slope is going rise over run. So in this case, to get up to the next point, I had to go up by 1 square, and I needed to go to the right by 2 squares. So in other words, my rise is up 1, my run is 2 squares to the right. So in this case, if slope is equal to rise over run, then we know that our slope is up 1 and to the right 2. So in other words, our slope is 1 over 2. And because from left to right, we're going in an upwards direction, so upwards being this way, downwards this way, then I say that this has a positive slope. This also makes sense in that we said we were going up by 1, so that would be positive. Our run is always positive. We ended up with a positive slope of 1 over 2. Now, just a quick note, had I chosen a point up here and a point up here, and my same starting point, I would have gotten a rise of 2 and a run of 4. What would have ended up happening is I would have had 2 over 4, but knowing that I need my slope to be in lowest terms, I would have reduced 2 over 4 to be 1 over 2 and ended up with the same rise over run. So if you happen to choose points further away, That's totally fine. You're just gonna have to do some reducing of fractions if there was a closer nice point. Personally, I just like to choose the two nice points that are closest together, and then I don't have to worry about reducing a fraction. Let's take a look at our next one. So for line 2, I'm going to start with my furthest left point. Like a book, I'm going to read left to right. And as I travel along, I notice that there's not really any other nice points all the way until that last final point. So I'm going to plot my final point there. And in this case, we've got a lot of counting to do for our rise. In this case, our rise is actually a decrease, so we're actually falling. We're traveling in a downward direction. However, our rise just means how much vertical distance have we gained or lost. So in this case, I've gone down by 1, 2, 3, 4, 5, 6 squares. So my rise is down by 6. How we put that into our slope formula is we put it in as a -6. For our run, in this case, we were only traveling 1 square to the right. And remember that we're always traveling from left to right for our squares, meaning that our slope is -6 over +1. As expected, this is a negative slope because from left to right, we are actually decreasing and falling down. We're losing height as if we're going down a mountain, so that is a negative slope. For a positive slope, we should see that we would have to climb upwards. For a negative, we would just slide down. Now, a couple tricky situations. Line 3 does not actually rise or fall from left to right. So if we look at line 3 here, we're actually traveling completely flat as we go from left to right. In this case, we say that the slope is actually 0. And that's because we have not gone up, which would be a positive slope, nor gone down, which would be a negative slope, meaning that we're right in this completely flat line where we have no steepness at all. In this case, our slope is 0, but we want to think about the fact that it's 0 over 1. So remember, every number is secretly over 1. And that just helps us to graph this line that if I start at this point, I'm not going to go up or down, but to graph my next point, I'm going to go 1 square to the right and plot a point. I'd go 1 square to the right again and keep plotting my points to make that flat 0 slope line. 0 divided by 1 is in fact just 0, so that's where our 0 slope is coming from. Another unique situation is line 4. So we've gone over line 3 where we have no rise or run, but we travel 1 square to the right. For line 4, we're just simply falling by 1 square each time, but not going left to right. So start at the top, and then I just simply go down by 1 square each time. So in this case, our rise, we can start from the bottom and go up, would be 1 square up each time. However, I'm going 0 squares left or right each time I travel. So what this means is that the steepness of the line is actually too large to measure. So if you type 1 divided by 0 in your calculator, it should tell you that you've gotten a math error. What we call that math error is undefined. And essentially, it's exactly what I just said. The steepness of the line is too large to even measure, so we can't even define how steep this line is. If something's perfectly vertical, we have no way of describing just how steep that is, so we call it an undefined slope. And that is a math term that if you're asked on a test, you should be able to communicate that a vertical line has a slope which is undefined. It's an actual mathematical term that we're going to ask you to write. Okay, for our following graph, we are going to practice calculating the slope of the lines. At this point, I'm going to ask you to pause the video, try it on your own, and then check your answer by replaying the video. I'll put all the answers there and do a little bit of talking through. Okay, for slope AB, we have a couple nice points that we can pick from. So if we're being smart, we would want to choose the points that are nice, that are closest together. So in this case, bottom left, and then we have one in the middle here. Traveling across, we can see that we are going up by 3, and we're going right by 1, giving us a slope of 3/1. Had I chosen the top point up here, I simply just would have gotten a rise of 6 and a run of 2. 6/2 would easily reduce to 3/1, and you get the same answer. Okay, next up for line CD, we have the case where we have a perfectly horizontal line, meaning that it's completely flat and we have a slope of 0/1 or just a slope of 0. For EF, we have two nice points here and here. I'm going down by 1, so we're going to have a -1 in the numerator, and to the right by 2, so we're 1 by 2. For GH, we have a point up here and a point here. We're going down by 2, so -2 is our rise, and we're going right by 1, so we have 1 in our denominator. For slope IJ, we have a vertical line. Remember that a vertical line is so steep we can't measure it, so we call this an undefined slope. Next up, for KL, we have a point here and another point here, meaning we're rising by 1, running by 2 to get +1 in the numerator and a run of 2 in the denominator. Just a note here, if you happen to pick any other point, so if you picked here or here or here, that we need to make sure that we're always reducing when possible. Okay, we're going to do a couple more to practice. So, example 2 says on the graphs below, plot lines that pass through the given point that have the given slopes. So, let's walk through these steps. For number 1, it says place your pencil at the requested starting point. So in this case, we're being requested to start at the origin of 0, 0. I'm going to start there. From there, we have a slope of 3/5. Remember, 3 tells us our rise, 5 tells us our run. So from this starting point, I'm going to go up 1, 2, 3, given that 3 is positive. Then I need to go to the right by 5. 1, 2, 3, 4, 5, and plot a point. To help us line up, we have our ruler. So make sure that you grab a ruler and use it to help you draw your line. We only actually need 2 points to connect our line, so we can simply connect these 2 points and draw out our line just like that with our arrows on the end. We need to make sure that we include arrows on the end of each line to indicate that these actually do keep going beyond the graph. We don't want to just draw a line and stop there, because the line doesn't stop there, the line's going to continue to go. It may be wise as you plot to also plot extra points to help you get a nice line. So in this case, even though our rise was up 3 and our run was to the right 5, we can draw more points by going in the exact opposite direction in terms of rise and run. So what that means is to get points on the other side, so on the left over here, I can reverse everything. So instead of going up by 3, I go down 1, 2, 3. And instead of going right by 5, I go left 1, 2, 3, 4, 5 to plot another point there, which is exactly on our line. So it's always wise to just follow the direct slope given of up 3, right 5, but we can reverse that to get points on the other side by going down 3, left 5. Okay, for our next one, we're going to start at 0, 0. And in this case, we have a slope of -4/3. So that means we're going to go down 4, 1, 2, 3, 4, and to the right 3 since we always run right. 1, 2, 3, plot your point. I'm going to help myself out by plotting another one up to the left. So I'm going to go up 1, 2, 3, 4 and go left 1, 2, 3 to get that next point. That gives me 3 points to line up and connect with a ruler to make a nice straight line. Then I make sure that I'm putting arrows on. The other important thing here is double check that your lines have extended all the way to the end of your graph. We shouldn't see any lines that are only small lines on the grid. They should take up the entire grid from end to end and cover all the squares. For our next one, we are starting at a point of 0, positive 5. So that means I'm going to go nowhere left or right, but I'm going to go up 1, 2, 3, 4, 5 squares. In this case, it gives us a slope of -3, which doesn't tell us our run. That looks like it could be an issue. However, we want to remember that any number is secretly over 1. So in this case, -3 is our rise, +1 is our run. It's our hidden denominator. Whenever you don't see it there, remember that it really is there. We just need to remember that it's over 1, meaning it's a run to the right of 1. So from here, I'm going to go down 1, 2, 3, run to the right by 1. I'm going to continue plotting points, down 3, right 1, and then connect all of my points with a line that extends from the top to the bottom of the graph and has arrows on the end. Okay, feel free to try D, then see if you can figure out E and F. Those ones are a little tricky though, so if you're struggling, then feel free to pause the video now, try D, then replay it to work on E and F. Okay, for D, we're starting at -2, -4. So in other words, I'm going 2 to the negatives on my x-axis and down 4 on the y-axis. From there, I'm going up 2, and I'm remembering that this is really over 1. So I'm going to go up 2 for my rise, right 1 for my run, and plot a point. Then I can continue plotting points, going up 2, right 1, and connect all of them with a nice straight line with arrows on the end. For E, I'm starting at 0, -3. And for a slope of 0, we just want to remember that that means that that is a completely flat line. That means that I'm just simply running through the y value of -3, and that's my line. For the next one, we're starting at +3, +4. And from there, we see that this has an undefined slope. Remembering that an undefined slope means we have a vertical line that's so steep we can't actually measure the slope. We're just simply drawing a vertical line through that grid line, and that is our line there. Thanks so much for listening to our introduction to the Cartesian plane and slope, and we will see you next time.